Okay, there's one more thing that we need to learn about scheme, and that's how to represent combinations of data. So pairs and lists are the fundamental data structures, and lists are just nested pairs. So in the late 1950s, computer scientists gave very confusing names to things. They called a cons a two-argument procedure that creates a pair. They called car a procedure that returns the first element of a pair, and coulder is a procedure that returns the second element of a pair. There are reasons why these names are what they are, but I won't bore you with the details. Nil is the empty list, a special value in scheme. Now, since everyone likes history, especially computer scientists, and we don't have that much history to remember, we have kept around these names for many years: cons, car, coulder, and nil. So you just need to remember what they mean. It's also the case that recursive lists are fundamental to Lisp. They have been forever, but they use a non-obvious notation. So a recursive list in scheme is a pair where the second element is either nil, the empty list, or a scheme list. And scheme lists are written as space-separated combinations. Then there's a dot. So a dotted list is something that has any value for the second element of the last pair, which means that it might not be a list. Alright, that's a lot of description. Let's look at the examples to understand how scheme lists work and how their notation works out. So, if I say that x is the cons of 1 and 2, that's a two-argument procedure that creates a pair, and then I look up x, it says 1.2. Now the dot tells me that there's some arbitrary value for the second element of the last pair, namely 2. 2 is not a list, it's just a number. The car of x is 1, the coulder is 2, but if I cons 1 with consing 2 with consing 3 with consing 4 and nil, so this is a list, therefore this is a list, therefore this is a list, therefore this is a list, I get 1, 2, 3, 4. So if you see a combination without any dots in it, that means it's a recursive list, which are just called lists, because everything in scheme is recursive. It's just so obvious. So this structure, 1, where the second element of the pair is the list 2, 3, 4, is just written as 1, 2, 3, 4. So that's not a well-formed list, but that is. Okay, so how do I create a pair? That's cons 1, 2. And how do I create a list with 1 and 2 in it? Well, that would be cons 1 with cons 2 nil. Another way to create a list is with the list procedure, which is built in. What's the car of the list 1, 2? It's 1. And what about the coulder? Well, that would be the list that contains 2. So how would I compute the length of a list? Well, I'll use recursion. I'll say if it's the case that S is nil, and in scheme, the predicate for checking whether something is nil is the null predicate. So this is just one big symbol called null question mark, which tells us whether or not S is nil or not. So nil things have 0 length. Otherwise, they have one more than the length of the rest, or coulder, of S. So if we load this file, then we can define S to be at the list 1, 2, 3, 4. There's S, and its length is 4.